Solving system equations using substitution. So now all systems can be solved by graphing. Like you look at the one here, I have no idea where they cross, right? It crosses right there. Is that like 2.1? Is that, or 1.5, 1.6? Who knows, right? We cannot do this by graphing unless we have like a decimals or something. Over here, I could solve this by graphing maybe if I keep on extending my graph, but that's gonna be tiresome. So we want different methods to solve a system. So one of those methods is by substitution. Another method would be by elimination. We'll do that in a different video. So when we solve by substitution, we generally want to follow these steps. Isolate a variable. It does not matter which one. And then we're going to substitute that variable into the other equation. And then we'll solve that equation. And lastly, we want to, once we solve that equation, we're going to substitute the answer in back into the first equation to find remaining variable, to find the one we haven't solved yet. Okay, so those are the steps. Let's look at this first one here. So we want to isolate a variable by itself. So it doesn't matter if it's x or y. In this case, look at right here. Y is already by itself. Y equals 3x. So that's step one done. Y is equal to 3x. Done. Now what we want to do is substitute this guy into this one, right? See, y equals 3x. So instead of the y here, we're going to substitute in 3x. So it's going to be 3x instead of the y. We're going to plug this guy in to there. So it looks like this. 4x plus 3, and then instead of the y, it's 3x. And then we still have equals 26. Right, so it's the same thing as we have here, but instead of that y, we're substituting our 3x for y. Now we just got to simplify this. So we have 3x times 3x is 9x plus 4x equals 26. And remember, these are on the same side of the equal sign. So first thing we do is we're going to simplify. We can add these up because they're on the same side. So I get 13x equals 26. And now we just got to divide by 13. We have x equals 2. Right, and hopefully you notice that we only solve for one variable. Right, so step 1, isolate the variable, good. Step 2, sub it into the equation, done. Step 3, solve the equation, good. Now we're missing a variable, so now we have to go back and plug it into the original equation, like the first one here, to find y. Technically, you can plug into any one, but the easiest way to do it is plug into the original. So we have to find y. So we have y equals 3 times x, which we now know is 2. We get 6. So there's my answer, 2, 6. Really, I should have a fifth step, which is check your answers. Check solution. And you can do that by substituting your solution into the equation, right? So x is 2, y is 6. Let's plug into the second equation just to check. Be 4 times 2 plus 3 times 6. Does that equal 26? So 8 plus 18, that does equal 26. So you go check your work to see if it's right. Okay, so we want to the second one here. Again, step 1, isolate the variable. Luckily enough for us, again, y is isolated, right? Y equals 6x plus 7. Done. So now let's substitute that into the other equation for their y. So it's gonna look like this: 3x minus 8 times y, which now we know is 6x plus 7, equals 34. So like that. Now let's distribute. So we have 3x. Right, when we solve this, we want to simplify the sides first. So let's simplify the left-hand side. So I'm going to distribute that -8 into both of these. -8 times 6 is -48. -8 times 7 is -56. And then again, I can add up like terms here. So these two are both x's, so I can add them up. Because again, they're on the same side, so just add them. That'd be -45 minus 56 equals 34. And now we would add 56 to both sides. These will cancel out. I get -40, oops, forgot the x. negative 45x equals 90. Now we divide by negative 45. And we get x equals negative 2. And again, I only have my x, so I have to go back and find my y. So let's plug it back into any one of these, but the original is the easiest one, or like the one we start off with is generally the easiest. Let's find y. So that's going to be y equals 6 times negative 2. That's what x is now, equals 7. So I get to be negative 12 plus 7. Remember, they are different signs, so we're going to subtract. So that's negative 5. Right, negative 12 plus 7 is negative 5. So our answer is negative 2 minus 5. Okay, let's move on to the next one. Now in this one, if you notice, right, step 1 is isolate the variable. None of the variables are isolated. So we have to get one of the variables by themselves. So let me look at the top one here. Let's look at this guy. So we have x minus y equals 6. I want to get a variable by itself. So I think the easiest way to do it is let's get x by itself. So what we're going to do is we're going to add y to both sides. And then we'll get x equals 6 plus y. So now that I have x by myself, I could plug that into the other equation, right? We're going to substitute. So we have x equals 6 plus y. So in this equation, instead of that x, it's going to be 6 plus y plus y equals 10. Right? So instead of the x there, we substituted this equation in x equals 6 plus y. So we have 6 plus y equals 10. And now we can add like terms. Remember, when they're on the same side, you just want to add them. So y plus y is 2y equals 10. And now we can just solve it. Minus 6. We get 2y equals 4 divided by 2 divided by 2. Y equals 2. And again, when you're not done, all we have is y. We need to find x. So we're going to substitute this back into our first equation to find x. So now we know x is equal to 6 plus y, but y is 2. So x equals 8. And if I put in a point, don't forget x comes first, right? Like over here, this is x and then y. So it's be 8 and then 2. So that's the way. Okay, so that's how we solve by substitution. Even when we have to isolate it ourselves. Next, let's talk about what happens. How does infinitely many solutions or no solutions work with substitution? Right, when we graph, this is the same line, right? We get the same line around top of each other. And then this is parallel lines, right? They don't cross. But how does that work with substitution? So let's solve it, see what happens. So over here, if you notice, y is by itself, y equals 3x plus 1. So we're going to substitute that into the other equation. So 6x minus 2 times 3x plus 1 equals negative 2. Right, step 1, after we do that, let's simplify this left side here. So I get 6x minus 6x plus 2 equals negative 2. These cancel, and I'm left with 2. Actually, that's actually a negative 2. Right, negative 2 times 1 is negative 2. So those cancel. I still get negative 2 equals negative 2. And it's like what we did before. If it's a true statement, this is true. Then it's infinitely many solutions. So just like before, if your x's cancel out and you end up with a true statement, infinitely many solutions. If you end up with a false statement, no solution. Like imagine the one here is going to be. So in this one, you notice the first one is not isolated. On the bottom, we do have y by itself. So same idea. Let's plug that in for the y on the top. So it's going to look like this. 5x minus parentheses 5x minus 4 equals negative 7. Like that, right? We're going to substitute this in for the y right there. And just like before, since it's on the same side, let's distribute. So I get 5x minus 5x plus 4. These cancel. And we're left with 4 equals negative 7. That is false, so this is no solution. So that's what happens, right? So that's how you know you have one of those, is when your variables cancel out and all you're left with is a statement. If it's true, infinitely many. Not true, no solution. Okay, let's quickly do one last problem. We're going to do an application problem that kind of ties everything together. So in this problem, a vacation resort offers surfing lessons and parasailing. If a person takes a surfing lesson and goes parasailing, they will pay a total of $175. On Friday, 16 people go parasailing and 20 people take surfing lessons. The resort collects a total of $3,000 and $3,101 for the activities. How much does each activity cost? So this is a different application problem than we've done before. So this one is not rate and change. It's not slope and y-intercept. Like we don't have initial value. We don't have a rate. We have like what the total value is. So in this case, let's set up our variables first, right? We're talking about surfing and parasailing. So let's say surfing's x, like it says there. Parasailing will be y. So surfing, and then parasailing. And what we have is a total value. So these are done differently. So we have to find what our values are. So they tell us that if you go surfing and you go parasailing, it's cost a total of 175. So that's our first equation. X plus y equals 175. And then if 16 people go parasailing and 20 people take surfing lessons, the total will be 3,000. So that's made our other thing. Now keep in mind surfing's x, so x is 20 people. So if 20 people do x, 20 people do surfing, and 16 people do y, it's gonna cost $3,101. So those are equations. Now if we want to solve this by graphing, we would have to put both of these in slope-intercept form. But even then, look at how high the values are. You don't want to graph that by hand. So I left the answer up here, right? If you graph this by hand, it's to be ugly, first of all, and big. But also, look where the answers are. We can't do this by hand, right? When we graph, you have to use a calculator or technology, and then we can solve it. So if you want to do that, it works, right? Use technology, you put in a slope-intercept form, plug into your calculator, or use decimals to figure out the cross. Totally works. If you want to do this by hand, we could do a substitution method. So let's do this real quickly. Remember step 1 of the substitution method, you want to get a variable by itself. So in this case, let's work with the top here. Let's get x by itself. I haven't done that in a while. So what I'm going to do is I'm going to subtract a y from both sides, right, to try to get the x by themselves. So that's minus y minus y. You're left with x equals 175 minus y. When we take the variable by itself, we're going to plug it into the equation over here, right? So we're going to substitute this guy in for my x over here. So it's look like this: 20 parentheses 175 minus y plus 16y equals 3,101. Then we want to distribute that 20 is both of these, so to get 3,500 minus 20y plus 16y equals 3,101. Add up like terms, right? Anytime you can, add up the terms on the same side. Simplify. So I get negative 4y equals 3,101. And we're trying to get y by itself. So it's minus 3,500 minus 3,500. I get negative 4y equals, what was that, 499? Negative 499. I'm using a calculator. Divide by negative 4. And you get y equals about 99.75. Right? And then once you have your y, you can go back up to here, plug it in and find your x. So let's do that real quick. Let's find our x. So it's going to be 175 minus 99.75. And we get, 75.25. So it's the exact same answer we got by graphing, right? Surfing costs $75.25. Parasailing costs $99.75, almost $100. Anyway, so you can see that, right? Do both methods work? Yeah, right? Graphing works. You need technology for it. Substitution you can do by hand. It is a little messy, but you can do it by hand. You don't need any technology for it. When would you choose graphing to solve a system? When would you choose substitution? Well, graphing, I'll use that if it's in y equals mx plus b form. Right? If they're both in that form, it's pretty easy to graph. I'll use that. Substitution I'll use if I already have a variable isolated. So you have like y equals something easy, or you have x equals something easy, and then you probably want to do a substitution method. Anyway, that's the video.